إذا الأمجاد قد عظمت فللأمجاد بانيها، ومن يسعى إلى العليا سيدركها بما فيها، ويبني مجده جذلا فروح الفذ يعليها، ليصبح همة تروي عن العليا مغانيها.
Assalamu alaikum and welcome to another exciting, explosive, dynamic episode of the ITV Math Show. I'm your host and presenter Mohammed Kota, from shooting live here from Johannesburg, South Africa. Guys, 2016 is a bumper year, right? We had our challenges in 2015. The country had its challenges with regard to mathematics. We saw the low pass rates, what had happened. And alhamdulillah, when we got all the feedback from our ITV Math Show last year, it was only positive feedback. So guys, we here again. Remember, we are shooting now every single day, guys, Monday through to Thursday, 3:30 to 4:30 Central Africa time. Your channel to watch, channel 347 ITV. Guys, we are now dealing with, today's topic, we are dealing with inverse functions, grade 12. And what we're going to try and do on a weekly basis, guys, is try and cover the topics that you are currently doing in school. So grade 12s, I know what you are doing. We are keeping ourselves abreast. We are keeping our finger on the pulse. We know what topics you have done for the year. Excuse me. Let's get started. You guys have started this year with sequences and series. You did sequences, you did series, you did sigma notation. Many of the schools, immediately after that, we're following the year planner from the Department of Education here in South Africa. The next topic that you had was the inverse functions. That's what we're going to be doing today. And then obviously I know that you guys, many schools have already introduced finance and the compound and double angles in trigonometry. Okay guys, now what we're going to be doing episode for episode is now showing you working in conjunction with what you are doing at school. So basically you can come home, tune into the TV and or go onto our website itvnetworks.tv, click onto the ITV Math Show and you can watch all these programs. The minute your teachers do it in school, you come back, watch the program, you can record it on your PVR if you have PVR, if you have the privilege of having PVR, record the show and then watch the show to reinforce the concept and maybe see it from a different perspective and get a better understanding. Remember, mathematics, guys, is about understanding. It's not about memorizing. Yes, we can memorize certain templates, but you need to understand what is happening in the topic step by step so that you can have a better understanding so that you can apply it in the exam situation. Guys, 2016, we would like to see a national improvement in mathematics results. Every province is screaming for mathematics. And this is the show to watch, guys. This is the show for you, from grade 8 right up to grade 12. Okay, guys, we're starting with the inverse function. Right, now the inverse function is not a function on its own. Inverse function is a concept, is a law that has been, that will be applied to all your functions that you have been introduced to in grade 10 and 11, right? Remember, today's show is for grade 12s only. Grade 11s, or the smaller grades, you don't need to know the inverse function. The inverse function specifically relates to grade 12 concept, to grade 12 content. Right, let's get started here, guys. The inverse function for grade 12. What is the inverse function? Let me explain to you. Right, if I gave you a graph, let's take f of x. Now, like I said, the inverse function can be applied to all functions. So whether it be your straight line, which you all know, that you've been introduced to, and that was given by y is equal to mx plus c. The inverse function will be applied to your parabola, and you know that the parabola is given by y or f of x. Y is equal to ax squared, let's just put it, ax squared plus bx plus c. It will be applied to your hyperbola, and the equation that's given is y is equal to a over x. Or the inverse function can also be applied to your exponential graph, and that you know y is equal to a to the power x. So these are the four main types of graphs that your inverse function will be applied 2. So let's start with a straight line graph. We'll do a couple of examples. It's one basic rule. If they tell you f of x is equal to 4x plus 20, right? We know this is given in the form at grade 12 level, even grade 11 level. You should be knowing this already, that f of x is equal to 4x plus 20. That, guys, is a straight line graph. Okay, so now they say give the inverse function. Give the inverse function of f of x in the form f of minus 1 x is equal to. Right? That is the question in the exam. That's how it will appear. Give the inverse function. And that's exactly what we're dealing with today, guys. The inverse function. Right. What is the rule? So even before we start with this, that's the style of question, so that you get familiar. You need to familiarize yourself with the type of styles of questions that will be asked. So the type of question number 1, give the inverse function. Now I hope by now that you have got a K-Way. It's a new series. It's a brand new year. What I'd like you, the viewer, to do is get a 192-page hardcover book. You can get it at your local stores, right? Stationery stores. Get a book, cover it nicely, call it the K-Way and ITV, or just call it the ITV Math Show. Put it down there, and topic for topic, when we give you questions, remember the purpose of this is for you to rewrite your own study guide in your own handwriting, so that you understand exactly what is going on. So every time you write a test or every time you write an exam, you refer to those notes, right? Make sure you have your scientific calculators ready, you got your pens, and you've got your ITV math book ready with you. Okay? Remember, start your own ITV math book. So, what is the rule? What is the rule for the inverse function? And let's put the rule down. Okay? In fact, let's do it there on the side. Let's go here on the side, and let's put down the rule for the inverse function. Rule for inverse function. Right. It's one basic rule that's broken up into 2 components. Step number 1. So let's put it down in 2 steps. And remember, we're going to be following these rules religiously. Mathematics is understanding rules. If you are faced with a question in the exam and you don't know how to answer it, it merely means that you don't know the rule, or maybe you know the rule, but you don't know how to apply the rule. Okay? So here's the rule. Step number 1, you swap the x and the y. You swap the x and the y. So you've got x. Remember, f of x refers to y. So you swap the x and the y. That's step number 1. And step number 2 is you make y the subject of the formula. So put this rule down, guys. You've got your K-Way rule book. You've got your book down, or your ITV rule book down. Put there the rule for the inverse function. Step number 1, and this rule will apply to all functions. Step 1, let's follow this rule. So that's the question in your answer. Let's start off with f of x is equal to 4x plus 20, right? And that is y. Remember I said f of x refers to y. So y equals 4x plus 20. Copy and paste. That's step 1. Swap the x and the y. So where is x? Where is y? That's y. That's x. We need to swap it over. So swap the x and the y. So you're going to have x is equal to 4y plus 20. We all got that? What have we done? We just swapped over the x and y. And what do we need to do now, guys? We need to make y the subject of the formula. So now we take the 20 on the other side. So x minus 20 is equal to 4y. Right? We want to make y the subject of the formula. So divide by 4, divide by 4, divide by 4. Y is equal to x over 4, which is a quarter x. Try and keep it aside. We can say x over 4, but x over 4 and a quarter x is the same. But we want to keep it in y equals mx plus c. So keep the quarter as your gradient. So divide by 4. Remember, we're dividing by 4. Divide by 4. Divide by 4. It's an equation. What I do to the right, I need to do to the left. Divide by 4. There's it, a quarter x minus 20 divided by 4 is 5. So there we go. We've swapped the x and y. We made y the subject of the formula. But they want it in the form f of minus 1x equals, so instead of y, we just put f of minus 1x is equal to a quarter x minus 5. And there we go, guys. Very simple. To apply the process, we swap. What is the rule? Let's repeat the rule. Let's understand the rule. We swap the x and the y, and we make y the subject of the formula. Swap the x and y, make y the subject of the formula, and call it f of minus 1, h of minus 1, g of minus 1, usually refers to the inverse function of the original function. Okay. Now remember something. We are teaching you. We are assuming that you know absolutely nothing. Remember, some of you have done this in school. Some of you are seeing this for the very first time. Right? So you need to hang on. For those of you who are watching it, and for those of you who have never, grade 12s, who have never been introduced to this topic before, you need to hang on to every word, because we're explaining it to you thoroughly, assuming that you know absolutely nothing about it. All right. Now, I want you to listen carefully. The question appears, is the inverse function of the original function, is it a function? Is it a function? Now, the question that you may ask yourself, what is a function? What do you mean is the inverse function a function? And that's what I'm going to be explaining to you now. Remember, we've got now, that's a straight line graph. The inverse function is also a straight line graph given by y is equal to mx plus c. Okay, before I continue, let me explain to you what is the difference between functions and relations. You have been introduced, this is for grade 10, 11 and 12, because grade 12s you have been introduced to this one concept in grade 10 already. What is a function? What is a relation? Okay, so they want you to, they ask you in the exam, is the inverse function of the original function, is it a function? Now in this case, it's a straight line graph. So you got two straight line graphs, your original straight line graph and your inverse function straight line graph. Is a straight line graph, is it a function? Yes, it is. Now they will ask you in the exam, why? Substantiate. Give a reason as to why you are saying that it is a function. So let's do this. Let's explain to you the difference between functions and relations. Okay, so that was your first example. I hope while I was talking, many of you were listening as well as taking this question down. Okay, let's go on to, let's explain to you what are functions and what are relations. Okay. So let's put down here, what is a function? What is a function, guys? A function is a one-to-one relation. Listen carefully and you can write this down. It's a one-to-one relation. Meaning that for every one x value, you only have one y value. For every one x value, you only get a corresponding and a different y value. One x value to one y value is a function. One x value. So basically, if we take a straight line graph, just to show you, there we go. That's a straight line graph, the blue graph, that's your axis. If I take an x value here, there's an x value, and I go up here, and I go there. For one x value, I get one y value. For another x value, anywhere on your graph, I get another y, a different y value. So for every one x value, there's it, one x value to one y value. So one x to one y will be a function. It's always a function. One x value to one y value is a function. Right. Even if I've got many x values, let's put it, many x values to one y value, that is also a function. So there are two types. One is a one-to-one relation like this, one x value to one y value, or many x values to one y value, meaning, here we go, there's your Cartesian plane, that is a function, that is a graph. Let's say the graph here, y is equal to 2. We've got many x values. Notice, x, no matter what value, no matter what x value you choose, you only get one corresponding y value. Many x values to one y value is still a function. Okay? Remember this. A function 1 to 1. One x value to one y value. Or many x values to one y value will still remain a function. I've just given you 2 examples of a function. I hope you guys are taking these notes down. Remember, these are the notes that you are going to be using in order to make yourself understand the topic. Okay. And it's a very simple concept. Inverse function, very easy. We said the rule for inverse function, swap the x and y and make y the subject of the formula. Okay, let's erase. Right, I hope you've taken this down. That is a function. So let's put this down. Function, one x value is to one y value. Okay, what is a relation? And that is the difference, guys. The function and a relation. The 2 major concepts that you need to be able to identify as a grade 12 in your examination. If a function is a one-to-one relation, or we can also say many-to-one, then a relation must be the opposite of it, meaning that it's a one-to-many relation. A relation is a one-to-many relation. A function is a one-to-one, a relation is a one-to-many, meaning that for one x value, you get many or multiple y values. Okay, let's give you an example of a relation. Right, we take a graph and we take a graph that goes like that. Okay, we take a graph that looks like that. You've got one x value. You got one x value. If I took a line or if I took a ruler, what we call the vertical line test, the straight line test, which your teachers should have or will explain to you in school, should have explained to you already. Right. You do the vertical line test. So you take a ruler or you take a pen and you put a line going straight through there. How many times does your graph cut this one red line? It cuts at 1, 2, 3. So as you can see, for one x value, you've got one y value, you've got another y value, you've got another y value. So one x value gave you 3 y values. One x value gave you many y values. So therefore, it's a one-to-many relation. So is this a function? No, not a function. What is this? It is a relation. Why? Because for one x value, you have many y values. So that is the difference generally between a function and a relation. Function, one-to-one or many-to-one, and a relation is a one-to-many relation. For one x value, you have multiple y values. And what method can we use here? We use what we call the vertical line test. Right? We use the vertical line test in order. Remember, not a horizontal line test, a vertical line test. You take a ruler, assume that this red line is a ruler, put it through your x values, see how many times does it cut your graph. For one x value, it cuts multiple times, so immediately it's a no-brainer. Cannot be a function, it must be a relation. Okay, so let's put down about 3 or 4 or 5 different graphs, and let's identify on screen quickly what, let's see whether you can identify whether the following graphs are functions or whether the following graphs are relations. So guys, I hope you have taken this down. Guys, welcome back from the ad break. We're busy with grade 12 inverse functions, right? You tuned in to ITV channel 347 you tuned in to the best math show in the country at the moment. Right, remember we said we're doing the inverse functions for grade 12. This is work that you are currently doing at school. Most schools have just finished it or are just introducing it at grade 12 level. Right, remember we're following the CAP syllabus. The CAP syllabus in South Africa at the moment, and we are dealing with the inverse function. Right, guys. Before we cut for an ad break, we said that when we get back, I'm going to show you different graphs. So let's go through, let's identify which of the following graphs are functions and which other of the following graphs are not functions, meaning that are relations. I explained to you before the break what is the difference between a function and a relation. Just a quick recap. What is a function, guys? What is a function? Look into your notes, what we wrote before the break. A function is a one-to-one relation. For one x value, you have many y values, or for many x values, you have one y value. That is a function. What is a relation? It's a one-to-many relation, meaning for one x value, you have many y values. So even if we drew, I'm just going to give you some rough graphs here. Right? Let's see which of the following graphs. So we got a straight line, we got a parabola, we got a parabola going in that direction, and we got a graph going in that direction there. Okay, we say, right, and in fact, I'll give you one more. Let's put one more here on the side, and we've got a straight line going through there. So that is 0, 0, 0, 0, and 0. So I'm just giving you rough sketches. 1, 2, 3, 4, 5 different functions. Let's see. I want you to identify. Let's use the straight line test. So we're going to say, are the following graphs functions or are they relations? Let's just put F for function, R for relation. Now I said we're going to be using the vertical line test. So what you can do, guys, what you can do is you can take your ruler, or you can take a page and do your vertical line test. Even take your hand, put it like this, and let's go across. We're doing the vertical line test. We're seeing we've got one x value, we've got only one y value. And you go across, for every one x value, you've only got one y value there. So therefore, this must be a function. Let's do the same on this. Let's take an x value there, you got one y value. Let's take an x value there, you got one y value. Take an x value there, one y. So for every one x, you get one different y value. So therefore, it must be a function. Let's take this graph here. Here's an x value. If I do a vertical line test and I put a ruler across there, how many times does the graph cut your ruler? It cuts there. So you got one x value, you got a y value at the bottom, you got a y value. So for one x value, you got many y values. Is it a function? No, it's not a function. If it's not a function, what must it be? It must be a relation. Remember, that's a function, that's a function, that's a relation. Again here, if I took an x value here and I did a vertical line test, one x value, how many y values? It cuts on the top, cuts here, and cuts there. So basically, we've got 1, 2, 3. 1, 2, 3 y values. One x value, 3 y values. Is it a function? No, it's not a function. What is it? It's a relation. Let's look at this graph. We got one x value, we got one y value. A different x, we got one y. Different x, one y. Different x, 1y. Different x, 1y. One x value to many y values. In fact, many x value. This is a many to one. Many x values to one y value. Many x to one y is still a function. It is not a relation. Right? One x to many y will be a relation. If you've got many x to one y, it is still regarded as a function. So here, this is just for you to identify which of the following graphs are functions and relations. Okay, so we've done the straight line graph where I gave you the function, the one that we cut before the break. What did we do? We did f of x was equal to 4x minus 20, and then we gave the inverse function. And what was our inverse function? We swapped the x and y. We made y the subject of the formula. We got f of minus 1 was equal to a quarter x minus 5. Right? 1 over 4x, or x over 4 minus 5. And it was still a function. Because both graphs, both straight line graphs, that's the one graph. The other graph will go in the opposite direction. Right? So you've got both graphs are functions. Right? So is the inverse function of a straight line a function? Yes, it is. Is the inverse function of a straight line a function? Yes. Let's look at the parabola and let's determine whether the inverse function of the parabola is a function. Okay. Let's take a graph. Let's take a graph. This is a very popular one. This one has been given. The next graph has been given in many, many past papers. In fact, you have seen it in your exam. So let's put it down. Let's see whether you can do this. We're going to be cutting for an ad break now. So what I'm going to do, guys, I'm going to put this function down. We're going to call it f of x is equal to 2x squared. That is a parabola. That is a parabola. Why is it a parabola? Because it is squared. F of x is equal to 2x squared. Give the inverse function. I want you to do this in your graph, and I want you to sketch it. Sketch the inverse function also. Give the inverse function of f of x in the form f of minus 1x is equal to whatever. Okay, guys, we're cutting for an ad break. Give me the inverse function. Rewrite the inverse function. Show me all calculations. Sketch the inverse function. And sketch during the ad break. Guys, you got 3 minutes. I'll see you guys when we get back.
ليصبح همة
Guys, welcome back to the ITV Math Show. I'm your host and presenter, Mohammed Kota. Guys, we started before. What did I give you before the break? I told you we started with f of x is equal to 2x squared, which is a parabola. Remember, we're doing the inverse functions. For those of you who have just joined us, we're doing the inverse functions for grade 12. Right, I gave you, that's the question. Q for question. F of x is equal to 2x squared, which is a parabola. Give the inverse function of f of x in the form f of minus 1x equals, and sketch the graph as well. So in your answer, we've got the rules there. The rule for the inverse function. What is the rule? We said step number 1, swap the x and y. And step number 2, make y the subject of the formula. Let's see how well you've done. Okay, so if the original was y is equal to 2x squared, let's give the inverse function. I said swap the x and y. So x is equal to 2y squared. So we swap the x and y. Let's make y the subject of the formula. So divide by 2, y squared is equal to x over 2 or a half x. So now find the square root, y is equal to the square root of a half x. And there we go, guys. We found plus or minus the square root of a half x, and that is the inverse function. They want it in the form f of minus 1x. So just take out the y and say f of minus 1x is equal to the square root of a half x. So that was your original. Let's just put it here, just so that you can see. That is the original, and that is the inverse function. Right? That's your inverse function. So your original, y is equal to 2x squared. Your inverse function, swap the x and y. We made y the subject of the formula, and you'll get 3 to 4 marks for that. Okay. Now they say sketch the graph. Sketch the graph. So let's look at what the original graph looked like. So you had the original graph here. Right. Y is equal to 2x squared. We know our c value is 0. Remember ax squared? Remember your normal formula? Ax squared plus bx plus c. There's no bx, that means your turning point is on your y-axis, and there's no c value, or 0 being your c value. It means that the graph goes through 0. So if you had to sketch this graph, the original graph here would look like that, and that is graph f. That is your parabola, graph f, for the function 2x squared. Right? That's your graph, 2x squared. Right. Now they tell you to sketch the inverse function of this graph on the same set of axes. Right. Now we know that the original graph, the two arrows are pointing to the positive y. It's pointing to the positive y. As you can clearly see that the arrows on your graph are pointing to your positive y. So in which direction? Remember the inverse function, we're swapping it. So that means the inverse function now will be pointing to the positive x. And that, just to show you, you don't need to write this in your exam, but it's pointing to the positive x values. So if that is your original, the inverse function turns over. Your original points to the positive y. Your inverse function now will point to your positive x. Okay? And that is your graph f of minus 1. So there's your original graph, and that is the inverse function of your original graph. And they will ask you in the exam, on the same set of axes, sketch the inverse function of the original function. Okay? Right. So you might be asking, okay, so what if it was a negative graph? Right? Let's erase this. Let's erase this. What if they ask you, what if it was a negative graph? Meaning that your original graph was f of x was equal to minus 2x squared. Right? So how would your graph look like then? So in your answer, obviously you'd know now, because it's negative, because your a value is negative, the graph now goes in that direction, and it goes down now to your negative y. It goes down to your negative y. So in which direction will your inverse function? So if you had to sketch the inverse function of this graph on the same set of axes, if the positive graph went to the positive x, the negative graph goes to the negative x. And obviously you know that the inverse function now would go in that direction, pointing to your negative x. Okay, so you'll probably get about 2 or 3 marks for giving your inverse function, and another 1 or 2 marks just for showing on the graph in which direction your inverse function is showing. Okay, now comes the next question, which I asked you in the previous segment as well. They will ask you in the exam, and I'm going to dictate it to you, so I hope you write it down now. Is the inverse function of f a function? Right? It's an exam question. Is the inverse function of this function a function? When we started off, guys, with the straight line graph. Remember? And we established that the inverse function of the straight line was a function. Why? Because our original graph was y was equal to 4x squared minus 20, and then the inverse function that we calculated was a quarter x minus 5. Both are straight line graphs. Both the original and the inverse function were both functions. We're now dealing with a parabola. That's the original graph. That's the original function. Is the inverse function a function? What did I say? How do we test for the inverse function? We do the vertical line test. And what is the vertical line test? We choose any x value, and you can draw. This is the vertical line test. So you take a ruler or you take a page and you put it for one x value, you put it there and see how many times. How many times? So if that had to represent your ruler, how many times does your graph cut this line here? It cuts there and it cuts there. So you've got many y values for one x value. So you've got one x value, so it's a one-to-many relation. So is it a function? No, not a function. So let's make a note of it here. Right? If they ask you, is it a function? Is the inverse of a parabola or of this function a function? What would your answer there be? No, it is not a function. They will ask you, why is it not a function, right? There we go. It's on the screen. Is the inverse function of this parabola a function? You would say in the exam, no, it's not a function. Why is it not a function? Because it's a one-to-many relation, meaning that for one x value, you have many or multiple y values. Okay? Hope you guys have all taken this down. I hope you are all still paying attention. I hope you're all understanding what the concept is all about, right? We're dealing with inverse functions. So now we dealt with the parabola and we dealt with the inverse function. Let's take the hyperbola, or let's take an exponential graph, and let's see what the exponential graph would look like. Okay, so I'm erasing this, guys. Let's look at, in fact, let's start with the hyperbola. Let's start with the inverse of the hyperbola. The inverse of a hyperbola. But I'm not going to do of a standard hyperbola. I'm going to do with the shift in asymptotes. Shift in asymptotes. Now I'm going to show you a shortcut here, and I hope that you pay attention. Right, so I'm going to show you the shortcut here. So say they gave you h of x was equal to 4 over x minus 1 plus 2. And they want you to give the inverse function in the form h of minus 1x. So they want the inverse function of that function. Okay, there's two ways of doing it. Guys, if it's for 5 marks, you got to show all calculation. If it's only for 1 mark or 2 marks, then you do the shortcut. So here I'm going to put, this is the long method of doing it. So let's put long method of doing it, and let's put our shortcut. Right. Let's see. All we're going to do now, we got y is equal to 4 over x minus 1 plus 2. Let's now swap the x and the y. So x is equal to 4 over y minus 1 plus 2. Remember, inverse function, swap the x and the y. Let's make y the subject of the formula. Now this is purely algebra. All we're going to do now is make y the subject of the formula. So I'm going to take the 2 over onto the other side. We got x minus 2 is equal to 4 over y minus 1. Now x minus 2 is over 1. I want y on the top. This is an equation. This is a fraction. So now we're going to flip this side. We're going to flip that side. So what do we have here, guys? We got y minus 1 over 4. Y minus 1 over 4. We flip that side is equal to 1 over x minus 2. So what I do on the right, I do on the left. Because I want y minus 1 on the top, I flip the right, I flip the left. So y minus 1 over 4 is equal to 1 over x minus 2. I want y. So multiply this side by 4, multiply that side by 4. Y minus 1 is equal to times 4 times 4. 4 over x minus 2. Take the 1 over on the other side. I'm moving here to the side. Y is equal to 4 over x minus 2. Let's just write it a little. Let's space it out. Y is equal to 4. Y equals 4 over x minus 2. Minus 1 will go on the other side as plus 1. That is your inverse function. H of minus 1x is equal to 4 over x minus 2 plus 1. And that is the long way of doing it, right? By showing every calculation if the question was for 5 marks. If the question was only for 1 mark, if the question was only for 1 or for 2 marks, I'm going to show you a shortcut. Now, how do we develop a shortcut, guys? How do we develop a shortcut? We develop a shortcut by looking at the question, looking at the answer, and seeing the relationship between the two. So let's take the question. There is the question. There is your answer. Let's look at the two. Let's compare the two. I've got 4, I've got 4. I've got x, I've got x. I've got negative, I've got negative. I've got positive, I've got positive. So that all stayed the same. Look what happened. The minus 1 became, the 1 at the bottom became your q value, and your q value became your p value. Remember, a over x minus p plus q. So what had happened here? You got 1 and 2, you got 2 and 1, so basically the 2 just swapped over. So in order to, so the shortcut, we're now going to go h of minus 1x is equal to 4 over x minus and plus. These two just swap over. So now we have 2 and we have 1. So we just swap the 2 around. In fact, swap the 2 around. The 2 on the top becomes the 2 at the bottom. The 1 at the bottom becomes the 1 on the side. And there we go, guys. We've just swapped it over. In one step, we eliminated all of this, and you can only do this with a hyperbola with a shift in asymptotes. Guys, we're cutting for an ad break. I want you to do the next one. I want you to do, in the ad break, g of x is equal to minus 3 over x plus 2 minus 5. I want you to give me the inverse function in the form. I want you to do both methods in 3 minutes during the ad break. Do the shortcut and do the long method. I want the inverse function in the form g of minus 1x equals. And let's get back from the break and let's see whether you've got it, whether you get it right. Enjoy your break, guys. Guys, welcome back to the ITV Math Show. I left you before the break with the inverse functions. I told you to do g of x. That's the original function. We're doing this one here. I know this board looks hectic. For those of you who have just joined us, you're looking at the board and you don't know what's going on. Remember, this is math. Okay, so I left you before the break with g of x is equal to minus 3 over x plus 2 minus 5. I want the inverse function in the form g of minus 1x equals. For those of you who have missed the show, this episode will be uploaded on our website, ITV Networks. All right, itvnetworks.tv. Go up on the website within the next couple of days and you can review the show. So let's go here. Let's erase all of this because I know it's looking hectic. The board is looking full. Let's go back. We're doing the inverse function, and I said I wanted you to do both methods. I wanted you to do the shortcut as well as the long method. I did show you before the break how to do both of them. So that was the rule. Like I said, let's quickly recap on the rule. Rule for inverse function, swap x and y and make y the subject of the formula. I've been saying it over and over and over in the show just so that you understand it and you never ever forget what is the inverse function. So the original function here, let's write it nice and neat here. We've got, I think it's neat, g of x is equal to minus 3 over x plus 2 minus 5. Okay, remember, I'm only realizing now that as we stand here on the side and as I'm writing that way, it seems, I don't know if you've done this in sides, it's called the error of parallax. From the side, it looks like I'm writing perfectly straight. It's only when I stand this way, I see everything is written this way. But it's okay. I think you guys understand what's happening. I hope if you got any complaints, send it in to me. Make me feel bad. It's okay. Right, let's go now. That is the question. The answer, we want g of minus 1x. So what are we going to do now? We're going to swap the x and y. So let's see. Let's try and write straight, right? I've been corrected from studio. They say, please, Mr. K, start writing straight. Okay, oops. Math. So let's go. Y is equal to in fact, that was the original y. So now we're going to swap the x and y. We're going to say x is equal to minus 3 over y plus 2 minus 5. Are you happy? Is that straight? Let's see. Straight? Looks straight to me. Okay, let's go. Let's make y the subject of the formula. Take the 5 on the other side. We've got x plus 5 is equal to minus 3 over y plus 2. Remember, that's over 1. Now, we swap it over. We are making y the subject of the formula. So let's swap that side. Let's swap that over. So what do I have? I've got y plus 2 over negative 3 is equal to 1 over x plus 5. Multiply this side by negative 3. Multiply that side by negative 3. We've got y plus 2 is equal to minus 3 over x plus 5. Take the plus 2 on the other side. So y is equal to minus 3 over x plus 5. Plus 2 will come on the other side as negative 2. And that we know is g of minus 1x. So g of minus 1x is equal to minus 3 over x plus 5 minus 2. Still going slightly, but it's okay. I think we're okay. Right, much better than it was. Right, so there we go. That was it, and we know we can do a check using the shortcut method. Negative 3, right? We've got positive, we got positive, we got negative, we got negative. The 5 comes to the bottom and the 2 goes to the side. So even if you had to do the shortcut, you would do the shortcut and you would just say g of minus 1x is equal to, I'm just going to write it here on the side, minus 3 over x plus 5 minus 2. You just swap the 2 over. And there we go. So we know we're right. We always have a checklist in math to do the shortcut and the long way to see whether the two answers tally. We know we are right. So that was the hyperbola. Now remember, this rule only applies for the hyperbola with a shift in asymptotes, where you just swap your p and your q values. Remember, this was given in the form, your original is given in the form a over x minus p plus q. So, right, your p value, your x asymptote, your y asymptote, the two asymptotes just swap over. The q becomes the p becomes the q, and that is the rule for the inverse function for the hyperbola with the shift in asymptotes. Okay, we're done with that. We're now going to go, let's do an exponential graph. Let's show you how to do the inverse function of an exponential. So put the heading in your books. Right, we're now putting the exponential graph. So let's go under the exponential graph. And that is given in the form y equals a to the power x, guys. That is given in the form y equals a to the x. Let's give you an example. Question in the exam, h of x is equal to 2 to the power x. They want you to give the inverse function in the form h of minus 1x. They want h of minus 1x. That's what they want. They want the inverse function. So in our answer, instead of we having y equal 2 to the x, we now swap it over and we now say x equal 2 to the y. Now they want you to give it in the form y equals. And they say, give it in the form y equals or give it in the form h of minus 1. Give it in the form h of minus 1 x equals. They want it in that form. They want it in that form. Okay, in the form y equals or h of minus 1. They don't want it in the form x equal 2 to the y. They want it in the form y equals. Now, what method in mathematics? Many of you have done this. Many of you haven't done this. The minute y is in the power and you need to make it the subject of the formula. So we're now going to say y is equal to, when we make y the subject of the formula, when y is the power, we attach a log. So it becomes a log graph. So it's log, what's your base? 2x. And that is your answer. H of minus 1x is equal to log 2x. And there we go, guys. That is it. Y is equal to log 2x. And you will get 2 to 3 marks just for saying that. So we swap the x and y. And you only do this for an exponential graph. Y is equal to 2 to the power x. So x equals 2 to the power y. And now we make y the subject of the formula. Y is equal to log 2x. Or h of minus 1 is equal to log 2x. Now they'll ask you, very likely, highly likely, to sketch both the graphs on the same set of axes. So let's sketch both the graphs, right? So I'm just erasing this here on the side so we can have enough space. let's sketch the two functions, guys. So we've got the first function here, which is your exponential graph. And you know your standard exponent. I'm drawing that graph there. H of x is equal to 2 to the power x. An exponential, positive exponential goes in that direction. You know a negative exponential will go in the opposite direction. We all know what is its intercept. 0 and 1. All exponential graphs have only one y-intercept, 0 and 1. Why? Whenever x is 0, 2 to the power 0, 5 to the power 0, 10 to the power 0, from your laws of exponents, any base to the power 0 is always 1. So that is h of x. So obviously the other graph, the inverse function, will have only, if the original graph has only one y-intercept, the inverse function will have only one x-intercept. And remember we said x becomes y becomes x. The two swap over. So instead of 0 and 1, this will become 1 and 0. And the log graph, the inverse function, will go in that direction. And that is your graph h of minus 1. And that is your log function. That's your exponential. Now remember, the log graph is the inverse of the exponential graph. So that is a positive log graph. A negative log graph will go in the opposite direction. Okay, guys, we're coming now to the end of the show. We will continue with the inverse function in our next episode, and then we will also begin with finance. So stay tuned to ITV, guys. Stay tuned to channel 347 ITV, to the best math show in the world. Right? I hope you guys have enjoyed today's show. I hope you've taken down all the notes, processed all the information, and I hope this is helping you to cement or to concrete all the concepts that are being taught to you in South Africa at your schools currently. From me, your host, Mohammed Kota, and from the rest of our studio here at ITV, we wish you the very best in mathematics. We hope you guys enjoyed mathematics as much as we are enjoying it here at ITV. From me, your host and presenter, Mohammed Kota, Assalamu alaikum wa rahmatullahi wa barakatuh.